So we're in our last section of this chapter 9.8 with factoring polynomials, and this section we're going to factor them completely. So we're just going to kind of use a lot of the different rules we've used in throughout the chapter and apply it to problems, and use some of the different techniques together in problems. So what I want to first do is I want to look at something like this, and let's take a look at this and say, okay, well, we have 2x times y, and we're subtracting 3y. Now, the idea is when we are doing these, right, when we're factoring these, we want to try to find a common factor, and we pull it out. So in this problem, okay, we have both the y, right, is in both of these parts. So what I can do is I can pull y out. So I could say, all right, well, this is y, right, times 2x minus 3, okay? Let's see. Let me try to find a different color here that makes it a little bit easier. Okay, I think that blue might be a little bit better. So, pulling out y, okay, from both of these. So I'm looking to see what number or what factor can I divide from both of these. So if I pull out y here, I'm going to end up with 2x minus 3, right? And if I reverse this, if I use my distributive property, I say y times 2x, well, that's 2x times y. And then y times negative 3, that's going to be negative 3y, okay? So at this point, that should be, you should feel fairly comfortable with doing these, okay? Well, what happens when you have something that might look like this, where I have 2x, okay, plus 4, or 2x times the quantity x plus 4, minus 3 times x plus 4. Well, if you'll notice, this thing right here, okay, is basically what y was up here, okay? It's really just kind of the same problem. So again, this part here, right, this x plus 4 is a common factor from both of these. So what I can do is I can pull x plus 4, I can take it out of both of them, okay? So if I take it from here, if I take it away from here, and I take it away from here, I'm going to be left with 2x minus 3, okay? And so it's just another sort of technique, another way of looking at some of these factors, to make it a little easier when you are finding common factors here. So really the idea is you just want to be able to make sure that you understand that a factor doesn't have to be one single number. It doesn't have to be one single variable. It's just some part of the product that is the same in both parts, right? So this product right here has a part that is x plus 4. And this product over here has a part that is x plus 4. Well, that is a common part, right? Which means it's a common factor. And you can divide it out from both of them and pull it out from both of them. Okay? And that's really just the idea there. All right? Well, let's kind of move on and look at some of these other ones. Okay? One of the other things they're going to talk about here is we're going to do this thing called factor by grouping. Okay? Well, there are 4 terms in this polynomial, okay? And none of them can be combined, right? Because this is x cubed, this is x squared, this is x to the first, and this is x to the 0, technically, okay? So what you're going to do here is we're going to group things, okay? We're going to look to see two pieces here, okay, that have common factors, okay? And so what I'm looking for is any 2 pieces that are going to have a common factor where the other 2 pieces are also going to have a common factor, right? So if I do x cubed and 3x squared, these have a common factor of x squared, and then 5x and 15 both have a common factor of 5. So we can group it that way. We could say, okay, x cubed plus 3x squared, okay, plus 5x plus 15, okay, and sort of do it this way. I'm going to group these 2 things together, okay? And now, here, what I have is I have a common factor of x squared. So x squared is going to leave me with x plus 3, okay? And then here I have a common factor of 5. So I'm going to say, okay, well, this is 5 times x plus 3. All right, and now you have a common factor of x plus 3 in both of these. So we'll pull out x plus 3 from both pieces, and I'm left with x squared plus 5. Okay? And then from this point, you also want to look and say, can I factor this even further? Okay, can I look at this and can I go further than this? Is there another common factor? Well, there's nothing in here that has a common factor, and then x squared plus 5, no common factors there, right? This is a perfect square. This is not. It's not a difference of perfect squares. There's nothing else I can do here, okay? Well, now this wasn't the only way we could have done this. In fact, let's go back and look and say, okay, let's say you looked at this and you said, well, no, x cubed plus 5x, these two have a common factor, right? They have a common factor of x in them, plus 3x squared and 15. Well, those have a common factor of 3. Well, let's do this. So I'm going to pull out x from both of these, and I'm left with x squared plus 5, plus I'm going to pull out 3 from here, and I'm going to be left with x squared plus 5. Interesting. Looks like you can take out an x squared plus 5 from both, and you're left with x plus 3. Okay, so there isn't necessarily one way to group these two things together, but what you are doing is you want to make sure that you combine pieces, okay, or look for two parts that have a common factor. So it wouldn't work, for instance, if you try to do x cubed and 15, because there is no common factor that you can take out from both of those. It doesn't help you at all, right? Yeah, you might be able to take an x from both of these, but what you're left over with, you don't have a common factor anymore, so you can't really, it's not going to really help you that much. All right, well, let's move on to another one, and why don't you take a second, pause the video, and why don't you go ahead and you try doing this one. Try to work your way grouping this one and factoring it out. All right, well, hopefully you had a chance to do this. And this is another one that has multiple ways of solving it. And so you might want to just look and say, well, okay, this has a x cubed and x has a common factor of x that I can remove from both of them. Okay, well, x cubed and 6 has nothing, right? These two have nothing, so I don't want to put those together, but maybe I'll do x cubed, and I could do 2x, right? That would have a common factor, and then I'd be left with negative 6 and negative 3x squared, and that has a common factor of 3 for both of those, so that would work. Or I could do x cubed and 3x squared, because I could take x squared from both of those, and then these are both even, okay? So either way there, it's going to work. In fact, let's go ahead and we'll just do both of them right now. We'll say, okay, x cubed, all right, plus 2x. We'll factor that one out. Okay, plus 2x. And then we'll say minus 3x squared minus 6. Okay, now I can't put a parentheses in here like this because that changes the value of this 6 here. So what I think I'm going to do is I'm going to make this a plus a negative 3x squared and plus a negative 6, okay? And now I can group this together because it's all adding. Okay, hopefully that makes sense. And so let's go ahead. Let's take out x from here, and I'm going to be left with x squared plus 2. Okay, and then I'm going to take out a negative 3 from both those. So I'm going to say, okay, plus, then we'll put a negative 3 on the outside. I'm left with x squared plus 2. Okay, and let's check it. Negative 3 times x squared, negative 3x squared, negative 3 times 2, negative 6. Okay, that works. And then let's go ahead and we'll pull x squared plus 2 out from both of those. And I'm going to be left with x, and we can just write it as minus 3. All right? And then we look inside of here. Can I factor any of this more? Well, x squared plus 2, I can't factor that anymore. X minus 3, I can't factor that anymore. So I'm going to leave it as it is, okay? Well, let's see. We could have also done this where we said, okay, x cubed, x cubed minus 3x squared, okay? And then I could have said plus 2x minus 6, right? And I could have grouped this one, and I could have grouped this one together. And then I'm going to pull an x squared from here, and I get x minus 3, plus I'm going to take out a 2 from here, and I'm going to get x minus 3. And then I have a common variable of x minus 3 here, right? Or a common factor of x minus 3 there. And that's left with x squared plus 2. Okay? And you'll see these two things match. Okay? Take a look at another one here. So we've got 4x cubed minus 44x squared plus 96x. So let's go ahead and factor this out. Well, I can look at this immediately and look and say, all right, these all at least are even, so I can factor out them. an even number at least, and then I can also factor out an x from all of them. And let's see, if I'm looking at 96, I know that that can be divided by 4 as well, and this can be divided by 4, and this one can be divided by 4. So let's pull out 4x from all of them and see what happens here. So now I'm going to have x squared, and then this will be minus 11x. And then we have, what do we have, 24? All right, 24 times 4, 24 times 2 is 48, 48 times 2 is 96. Yes, so 24. All right, so we've factored this. Now let's look inside the parentheses and say, okay, can we factor this? Well, I know that this lead coefficient is 1, so I'm going to say, all right, when this is negative and this is positive. So let's see, are there two factors of 24 that add to 11? Now let's see, I could do 12 and 2, that doesn't work. I could do 6 and 4. Now that it's a 10, we could do 8 and 3. 8 and 3 add to 11, so let's see if that one works. So we do 4x times x. Now they're both going to have to be negative here. Minus 8, and then x minus 3. And that looks like it's going to work. It looks like when I factor this or multiply this out, I will end up with the right one. So let's see, x times x, x squared, good. Negative 8 times negative 3, positive 24, those match. So now let's look at our inside, right, our middle terms. So we have x times negative 3, negative 3x, negative 8x, that adds up to negative 11. There we go. So we got it. Looks good. All right, let's take a look at, let's try another one here. Okay, so we have 50h to the fourth minus 2h squared. Take a second and see if you can figure out what we're going to factor out here first. Well, hopefully you notice that they're, first of all, they're both even, so we can take out 2. And then there's h to the fourth and h squared here, so we can take out an h squared. And I'm left with, well, 50 divided by 2 is 25, and I'm going to have h squared. And then minus 2h squared, so this is going to be minus 1. Okay. Let's see if we can factor this anymore. Let's see, this is, oh look, 25h squared, that's a perfect square. And 1 is a perfect square. And it's being subtracted, so this can actually end up being, let's see, square root of that is 5h, square root of this is 5h, square root of this is 1, so 5h minus 1, and then we also have 5h plus 1. That's our difference of perfect squares that we've learned about in 9.7. Okay, and there you go. Looks pretty good. So finally, let's go ahead. Why don't you take a second? Why don't you pause the video here? And what I'd like you to do is, why don't you go ahead and try to factor this one out, and then set it equal to 0. Okay, and then try to figure out what all the possible solutions for this this question would be. Okay, so go ahead and pause it. Now, let me give you a real quick tip. Whenever you see the largest degree, right, the largest degree of your polynomial will be the number of solutions that this thing has. So because this is 3, you will have 3 solutions. Now, some of them might end up being the same number over and over again, but in this case, you're going to end up with 3 solutions. So go ahead, pause the video, and you try it. All right. Well, hopefully you had a chance already, and if maybe you're just trying to see if you got it right, or maybe you got stuck, and that's fine too. So let's go ahead and first thing I'm going to look for is I can say, okay, I can definitely pull an x out from all of this. So I get x squared minus 7x plus 12, and then this is equal to 0. Okay, and now I'm going to look for in the inside here, right? So I'm going to look at, all right, what two factors of 12? Okay, since this is positive, both of my factors are going to be the same. They're either both going to be positive or both going to be negative. In this case, they're both going to be negative. Okay, and so they're going to add. What two factors of 12 add to get 7? Okay, so I'm going to get x minus something and x minus something else. Well, let's see. I could try 12 and 1, but that's going to add to 13. Okay, if I did 6 and 2, that's going to give me 8, so that doesn't work. We could do 3 and 4. There we go. 3 and 4 adds up to 7. So x minus 3 and x minus 4. All of this together equals 0. Okay. And let's go ahead and check this. Let's see, x times x squared, or x times x is x squared, that works. And negative 3 times negative 4 is positive 12, and that works. And negative 3, right? This is negative 3x and negative 4x together makes negative 7x. That works. And then if I multiply this, I get x cubed. This times negative 7x squared, that works. And then 12 times x is 12x. Okay, everything looks good. Now, I get to this point and I say, all right, there's three possibilities here, right? X could be 0. Okay, because this is going to be equal to 0, right? If x is 0 here, that would make sense here. 0 and 0 and 0 all together make 0. Okay, so x could be 0, or x minus 3 is equal to 0. Okay, or x minus 4 is equal to 0. So then we also know that x could be equal to 3. Okay, or x could be equal to 4. Okay, so I know finally my answer is x equals 0, or x equals 3, or x equals 4. All of these are possibilities. Okay, and you could try plugging them in. You can cube all your answers and then square them and multiply them by 7 and do all that stuff at the top, and you'll see they do actually work out. So hopefully this makes a lot more sense to you. What I want you to do is go ahead and practice some of these problems. Come to class prepared. Make sure you ask if you get stuck on some questions, circle them, bring them in, so you have I have a good idea of where you're getting stuck, what you're having issues with. You can also, if you'd rather work on Khan Academy, you can do factoring polynomials too. Just be sure to let me know which of these two things you decide to do when we get to class tomorrow and add some of the word problems to it. All right, good luck, and see you tomorrow.